Hello, folks. Okay, before we get into this worksheet about using trig to find angles, I want to go ahead and recap how we've been using it so far. So go ahead and flip your guided notes over the backside, and we're going to recap. I want to do an example. If I were to give you a triangle that looks like this, a right triangle, where the 90-degree angle is in the upper left corner, and we'll call this left side 8, and we'll call the top side x. In this angle over here to the right, 37 degrees. So prior to today, this whole chapter has been about using trigonometry to solve for angles. The first and foremost thing, if you have not done so already, that you need to make sure that you remember is how to write down SOHCAHTOA and spell it correctly. If you can remember this and write this down, it helps you set up all of the trig functions, right? This means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is set up the ratio by opposite over adjacent. But we don't always just want to set up the ratio. We want to use the ratios to help us solve. So what we've done prior to today is we said, okay, let's go ahead and list out our information. The first thing we need to list every single time is a reference angle. And I'm going to choose 37 degrees just because it's there. It's the one that is already labeled on the picture. Remember, you can never use your 90-degree angle for a reference angle. Okay, from my reference angle, I need to figure out what is x, what is 8. Now, before I go ahead and do this, I want to label the hypotenuse. Identify your 90-degree angle. Hypotenuse is opposite of it, so I'm going to call that h. So now that I've labeled the hypotenuse, the other two sides from my reference angle are either going to be adjacent or opposite. Okay, so if I'm standing at the 37-degree angle, I want to know what is x. Is it adjacent or is it opposite? Well, hopefully you said adjacent. It is right next to x. It is touching x. 8, on the other hand, from this 37-degree angle is completely opposite of the triangle. It's totally across. So I know that that is opposite. So after you list your reference angle and your sides from what you know, then you go ahead and look up at SOHCAHTOA and you figure out which one of these, sine, cosine, or tangent, has adjacent and opposite, A and O, as the letters. The order doesn't matter, you just want to know A and O. Well, it's not sine, right, because sine has O and H. Cosine has A and H. It must be tangent. TOA has O and A. Once you identify which one you're going to use, then you set up an equation. It's going to be the tangent of, we always put our reference angle next to the trig function, so the tangent of 37 degrees is going to equal, remember this says that we set up tangent by doing opposite over adjacent. So don't go by the order that you wrote your list. You always need to make sure you put the opposite one first. So 8 over adjacent is x. So that's how to set up the equation. Once you set up the equation, the goal is to solve the equation or get x by itself. So typically we've been putting the left side over 1 and we cross multiply. So when we cross multiply that way, that's going to be the tangent of 37 times x. When we cross multiply the other way, we get 1 times 8, which is 8. Now, x is still not by itself, so we've got some more work to do. Right now, it's being multiplied by the tangent of 37, so we need to go ahead and divide both sides by the tangent of 37. So if we were to write x as an expression, it would be x equals 8 over the tangent of 37. So if I actually want to solve what it is, in your calculator, you need to do two things. You first need to check, are you in degree mode? So that's where you need to hit the mode button at the very top of your calculator. Make sure degree is highlighted. Right now, my pre-cal students have to be in radian mode, so they're always going to be changing their calculators to radian. So you need to make sure yours is back to degree. Then you type in your calculator 8 divided by the tangent of 37. If we round that to the nearest tenth, hopefully you get that x is approximately 10.6. So that's a little refresher of how we've used trig so far. This worksheet covers what happens when you want to find an angle. So after you list all your information, what if the reference angle is the thing that you don't know? How do we proceed? Well, before we do that, I have a question. It is, how do we solve for variables in algebra? For example, why do we divide both sides by 3 in the problem below? So I've got 27 equals 3x. Now, the majority of you, without hesitation, are just going to shout, okay, well, let's go ahead and divide both sides by 3. And that is true, right? You divide 27 divided by 3, and ta-da, you get x is equal to 9. But my question is, why? Why do you divide both sides by 3? And if I were there live, you probably are saying some things like, well, just because. That's what that's what we were told to do. And my question in return is, well, why don't we multiply both sides by 3 or add 3 to both sides or multiply 3 on both sides? And hopefully to that, you could say, well, because this is 3 times x is equal to 27. So therefore, in order to get rid of 3, we divide both sides by 3, right? So let's kind of write that down. Let's say since 3 and x are being multiplied, and you can shorthand some of these words if you like. We'll say to move 3, we must use the opposite, which is also sometimes going to be referred to as an inverse operation. In this case, the opposite of multiplication is division. So that's how we move stuff in algebra, right? We always do the opposite. If there are things being added and we need to move it, we subtract it from both sides. Well, trig functions have an inverse too. So we don't always have to just use them to set up ratios. We can use them to solve for sides and angles. So here's what you're going to do. If we look at this example, that the sine of r is equal to 3 over 6. On your calculator, so now I'm reading here in this little text box. On your calculator, you will use the second button to enter what is above the sine, cosine, and tangent buttons, which are sine inverse, cosine inverse, or tangent inverse. Literally, these are inverse functions of the trig function. So if you don't have your calculator out, make sure you go ahead and do that now. And again, you want to make sure that you're in degree mode. Once you change it once and you're using the calculator, it's not going to change back in the middle of your use. You should only have to worry about it one time. But if you haven't done so already, go ahead and make sure it's in degree mode. And then what's going to happen is, in order for me to undo r, right? If I'm trying to get r by itself and I want to get rid of sine, I need to go ahead and take the sine inverse of both sides to get r by itself. So it looks like to the negative first power, like it looks like a little exponent, but it's not. It's sine inverse. So what happens is the sine inverse of sine cancels, and we're left with just r on the left side. R equals sine inverse of 3 over 6. So in your calculator, you're following exactly what I just wrote in this text box. You're going to hit second sine, and it will input that sine, it looks like, to the little negative first button. So second sine and 3 over 6, and then you're going to hit enter. So you're following these steps right here. Second sine, 3 over 6, and that's 3 divided by 6, enter. And when you do that, you should get 30 degrees. So the biggest question and the biggest issue that people have in this chapter is, when do you use the second sine button, and when do you use the regular sine button? Well, here's your answer to that question, then I hope that you never forget it. Ready? You use the inverse trig functions. Use inverse trig functions. So that's when you hit the second button, right? Which are sine inverse, cosine inverse, and tangent inverse. You use these whenever we are solving for angles. Oh, misspelled it. So you're going to use second sine, second cosine, second tangent whenever you're solving for angles. Okay, so let's do some of these examples here. Before we use triangles, let's do some of the basics. This first set of examples says use a calculator to find each angle measure to the nearest degree. So number 1, it says sine of angle x is equal to 12 over 17. So I'm trying to solve for the angle. So if I want to get x out of there, I need to go ahead and take the opposite of sine is sine inverse. So it's kind of like dividing both sides or multiplying both sides or whatever, except you take the sine inverse of both sides. When that happens, you get x by itself. So x is equal to sine inverse of 12 over 17. It says round to the nearest degree. So in your calculator, you're going to hit second sine 12 over 17. And you should get that x is approximately 45 degrees. Okay, number 2, the sine of q equals 0.5736. So this one looks a little bit different, but you treat it the exact same. If I want to get q out of sine, I'm going to take the sine inverse of both sides, which is going to leave me with q on the left side, right? My sine and sine cancel. Q equals sine inverse of 0.5736. So typically we've been putting a fraction, but you're just going to put that decimal and it's the same thing. Round to the nearest degree, you get q is approximately 35 degrees. Now, this doesn't just work for sine. This works for all of the trig functions. So for number 3, I've got the tangent of E is equal to 0.4452. So instead of taking the sine inverse or inverse sine, I'm going to take the tangent inverse of both sides because it'll cancel out the tangent on the left, leaving me with E equals tangent inverse of 0.4452. Hit second tangent in your calculator, 0.4452, and get that E is approximately 24 degrees. Number 4, I've got the cosine of angle R equals 0.9455, so it works for cosine as well. So if I want to get R alone, I'm going to take the inverse cosine of both sides. Then it's going to leave me just with R on the left side equals cosine inverse of 0.9455. Therefore, to the nearest degree, R is approximately 19 degrees. Number 5, I've got tangent of S equals 6 over 10. So I'm going to take the tangent inverse of both sides. And that way on the left side, the tangent inverse and tangent cancel, and I'm left with S equals tangent inverse of 6 over 10. So can you hit the second tangent button? And we'll get that S is approximately 31 degrees. And number 6, cosine of W is equal to 9 over 22. So I will take the cosine inverse of both sides. On the left-hand side, cosine inverse and cosine cancel. So I'm left with W is approximately, or let's say W equals, I'm sorry. You only use approximately when you round. We haven't rounded quite yet. So W equals cosine inverse of 9 over 22. So W will be approximately 66 degrees. Okay, so that's the mathematics, the algebra behind plugging it into your calculator. Now, how does that even set up? Well, basically, we're going to treat these problems just like we did the problems we've done before. In order to find missing sides and angles, you always start with writing information. Write your reference angle, write what you know, write what you need to figure out. So for number 7, I'm going to choose, I'm going to list my information in green every time. So I've got a reference angle. And this time your reference angle, notice I don't have any other numbers other than 90 degrees. So my reference angle is going to be theta. Theta is this symbol here. Theta is how you pronounce that, theta. It's a Greek, and it looks like almost like a zero with a little dash through it. It's a Greek letter, and all it is, it's just a variable. So instead of me using like an A or a B or an X or something, typically in Trig we use Greek letters for variables. If you prefer using an X, that's fine too. You can just put an X there. It's the same thing. Okay, so if your reference angle is theta, then you list out your other stuff. So we've got 13 and we've got 4. So remember, you're using words like adjacent, opposite, and hypotenuse. So before we label, let's go ahead and determine our hypotenuse. Across from the 90-degree angle, here is H. So our hypotenuse is not going to be a part of this, right? It's just going to be 13 and 4. So 13 is the side that's touching angle theta, which means that is adjacent. And then 4 is completely opposite of angle theta, which is opposite. So if you have SOHCAHTOA written out, you're going to ask yourself, sine, cosine, or tangent, which one has A and O? Well, it's the same one from our warm-up. It's going to be tangent, or TOA. Okay, so once you decide that, then we can go ahead and set up our problem. The tangent of, you always put your angle here. Well, this time, remember, your angle is theta. It's that variable. So the tangent of theta is equal to, you follow this order, opposite over adjacent. So opposite is 4 over adjacent is 13. Okay, now if you just kind of take a step back at what you've done so far and you look at the problems for like 1 through 6, this looks exactly like those problems. The only difference is I have theta instead of a number or a letter from our regular alphabet. So we're going to follow the same steps. If I'm trying to get theta out of that, then I want to take the tangent inverse of both sides, right? The opposite of whatever theta is stuck in right now. So then if I do that, tangent inverse cancels with tangent, leaving me just with theta on the left side, equals tangent inverse of 4 over 13. And so you do that in your calculator. Second tangent, 4 over 13, and you should get that theta is approximately 17.1 degrees. My dog is drinking water. I wonder if you can hear him because he's loud and obnoxious. Thank you, Cupper. Okay, number 8, same routine, right? Let's list out our information. So I'm going to choose a reference angle. Again, my missing reference or my missing angle needs to be my point of reference because I'm not given anything else. So then from there, I have 7.7 and I have 14. So always list your hypotenuse first on your picture. Across from the 90-degree angle, I have H there for AB, my hypotenuse. 7.7 from theta, using words opposite and adjacent. 7.7 is completely across from that angle. It is opposite. Okay, 14 is right next to it, so it is adjacent. So again, if I look at sine, cosine, and tangent, I need to figure out which one has O and A. Again, we have TOA, or tangent. So if I set up tangent now, well, let's write down here. All right, TOA. Okay, so now let me switch to blue and we'll do the calculations. So if I set up my equation, tangent of theta is equal to opposite is 7.7 over adjacent is 14. And I try to solve for theta. Again, so let's pretend you just like go ahead and start to cross multiply and stuff. Well, if you start to cross multiply, let's pretend that you just kind of do what we've been doing. Then you get the tangent of theta times 14 equals 7.7. And then that literally doesn't get you anywhere because you're trying to get theta by itself. So then you actually end up backtracking. So here's the deal. We're solving for an angle. If I'm trying to get an angle by itself, I need to get it out of tangent. To do so, I'm going to take the tangent inverse of both sides. When we do that, on the left side, tangent inverse and tangent cancels. And I'm left with theta equals tangent inverse of 7.7 over 14, and that's what you plug into your calculator. So second tangent, 7.7 over 14 divided by 14. And you should get theta as approximately 28.81 degrees. Okay, number 9. List out our information. Reference angle. You start off these problems the exact same way every time. Reference angle, again, is what I'm looking for, so I'm going to call that theta. Then you're going to list, okay, I've got two sides, but they're both 3. So I've got 3 and 3. So before I figure out what these are, I want to go on my picture and list the hypotenuse, because that one's easy. I should never mess that one up. Opposite of the 90-degree angle is hypotenuse. So one of my 3's is directly next to theta, and it's adjacent, and the other one is opposite. So it really doesn't matter, because they're both the same number. The main thing, though, is I have A and O. So again, I have TOA, or again, I have tangent. Okay, so let's set up our equation. So then I've got tangent of, we put our angle theta, equals opposite over adjacent. So these are both the same. So I'm going to have 3 over 3. So if I want to get theta by itself, we're going to do just like we did the last couple of problems. I need to take the inverse tangent of both sides. So on the left side, if I do that, where's my blue pen? There we go. Okay, on the left side, if we do that, then we're left with theta equals tangent inverse of 3 over 3. So in your calculator, you'll hit second tangent, 3 divided by 3, and you should get theta is equal to 45 degrees, which is a lovely number compared to some of our other numbers we've been dealing with, which one day if you take pre-cal, you'll understand why that one's actually nice and pretty. Okay, number 10, let's list out our information. Always start with a reference angle. This one looks a little bit different than what we've just been doing because I actually have a number now. I have 37 degrees. Okay, so I've got a reference angle of 37, and I've got 11, and I've got x. So before I start listing, I want to identify my hypotenuse on the triangle. Across from the 90-degree angle, my hypotenuse is x, so that helps me list one of them. X is the hypotenuse. And then 11 will either be opposite or adjacent. So from the 37-degree angle, 11 must be adjacent because it's not the opposite side, it would be here completely across. Okay, so if I look at sine, cosine, and tangent, I need which one has adjacent and hypotenuse. Adjacent and hypotenuse. Hopefully you said cosine. If we set up our equation, we're going to have cosine of the angle. This one's different than the last 3 because your angle, now you actually have a number. Cosine of 37 is equal to, you follow the letter adjacent first. So adjacent is 11 over hypotenuse, which is x. Now, you don't want to take the inverse cosine of both sides because you're not solving for the angle. So notice I have a number there, and I'm trying to solve for x over here. So this is back to what we did earlier, where you want to put the left side over 1, and you want to cross multiply. So if you cross multiply, we're going to get the cosine of 37 times x is equal to 1 times 11, which is 11. Now, x is still not by itself. So I need to go ahead and divide both sides by the cosine of 37 in order to get x by itself. So I've got x equals 11 divided by the cosine of 37, and that's what you plug into your calculator. And you should get that x is approximately 13.77. Okay, number 11, let's go ahead and list out our information again. We always start with a reference angle, which, similar to the question that we just did, I actually have a number here. So I'm going to put reference angle 60 degrees. And then I've got 11, and then I've got x. So very similar number, actually the exact same numbers as number 10, but doesn't necessarily mean the exact same problem. So I'm going to go ahead and identify my hypotenuse first. Across from the 90-degree angle is 11, which is my hypotenuse. So 11 is h. And then from the 60-degree angle, x is either opposite or it is adjacent. Well, opposite means completely across, right? Opposite means I can draw an arrow. So it's not opposite, which must mean x is adjacent. So again, if you look at sine, cosine, and tangent, cosine is CAH. So we can use the cosine ratio to say that the cosine of 60 degrees is equal to adjacent over hypotenuse, x over 11. And then if we go ahead and, again, I don't want to use the inverse cosine because I already have my angle. I'm solving for one of the sides. So I'm going to put the left side over 1 and cross multiply. So if we do that, we get the cosine of 60 cross multiply down times 11 equals 1 times x, which is x. Now notice x is by itself now. I don't need to do anything else. So in your calculator, you just need to make sure when you type this in, the cosine of, when you type it or when you put cosine, it automatically opens a parenthesis. You need to make sure you close that parenthesis around 60 and then put times 11. And then you should get that x is approximately 5.5. Last one, number 12. Started off the same exact way. Our reference angle, we're back to a scenario where we have a variable there. We're solving for theta. And we have 11.9 and 10 as our sides. And we need to figure out what they are. So go back to your triangle, label the hypotenuse. Across from the 90-degree angle, there's h. So I know neither of my sides are the hypotenuse. 11.9 is completely opposite of theta, so that's O, and then 10 is adjacent. So if I look at SOHCAHTOA, again we are using tangent because it has O and A. So once you figure out what you're using, set up your equation. Tangent of the angle is theta, is equal to opposite over adjacent. So that'll be 11.9 over adjacent is 10. Now we're back to the scenario that we had earlier. Theta is my variable. It's stuck inside of tangent right now. So cross multiplying wouldn't do me any good. If I'm solving for the angle, I need to go ahead and do the inverse tangent of both sides. So that on the left side, inverse tangent and tangent cancel. I'm left with theta equals tangent inverse of 11.9 divided by 10. And that's what you plug into your calculator. Second tangent, 11.9 divided by 10. And you should get that theta is approximately 49.96 degrees. So this is how you use trig to solve for angles and sides. I mixed up the problems to kind of catch you off guard, but notice the steps are pretty much the same in terms of writing out all your information and figuring out should you use sine, cosine, or tangent. If you're solving for a side, that's where you cross multiply. If you're solving for an angle, that's where you do the second inverse buttons.